For this video, we are going to focus on our three main transformations that we've talked about so far, but now we're going to do them like in succession. We're going to do a composition of them, meaning we're going to do more than one at a time. Before we get started, I got to talk about a glide reflection here, where basically we are doing two things, but it's got a special name for it. A glide reflection is a translation followed by a reflection. But it's important to note that we are reflecting it over the exact same line that we are translating it. So this is kind of a lot here. So let's just take this footprint. That's what we're moving. We're moving it in this direction right there, which is really this line. We're moving it in this line right here. But then we're reflecting it over that line. Okay? Then they glide again, it looks like, and they reflected it back over. So they really did two glide reflections on this one. So your footprints actually is what this is kind of getting at. If you're walking in a straight line, your footprints are reflected because, they're opposites, right? So they reflect over a straight line as you walk down maybe the hallway in a straight line. So that's a glide reflection. Let's get into some problems here. So number one, translate the point -2, -3, which is, maybe I'll zoom in a bit. Translate the point -2, -3 up 2 units. That would be right there. Then reflect the result over the y or the x-axis. Over the x-axis would put it right there. What are the coordinates of the final point? Looks like it is at 2, -1. And I would like to label these as well. I'm going to have to erase them, I think, because I don't know. I'll label it A prime, B prime. Oh, I'm sorry, not B prime. Sorry, it's been a long day. Let me restart that. That one's going to be A. This is A prime, and this is A double prime. We're not going to change our variable. It's going to stay the same, our point. Next one, reflect 4,2 over the x-axis, or y-axis, sorry. Reflecting 4,2 over the y-axis. So let's go, where is -4,2? Right there. We're reflecting it over the y-axis. I'm actually going to have to erase this so we can see what we're doing here. So this would be like your A. Over the y-axis, well, it looks like it's 1, 2, 3, 4 away from the y-axis. So 1, 2, 3, 4 away would be right there. Translate the result to the left 2 units. 1, 2 would be right there. So this was A prime, and this is A double prime. What's the coordinates of our final point? Looks like it's 2, 2. Triangle JKL has vertices. J is at 6, -1. Again, a vertex is just a corner. A vertex is just a corner. So that would be J. K is 10, -2, which is right there. That's K. And L is 5, -3. I'm going to draw my triangle here. Okay. Graph that triangle and its image. So this is again the pre-image that I've drawn. But we're going to draw the image after a translation. And this is just another way to write it. Translation along 0, 4. So we're translating it 0 in the x direction, 4 in the y direction. 4 is up. So 1, 2, 3, 4. It looks like J prime is going to be right there. 1, 2, 3, 4. This will be L prime. 1, 2, 3, 4. That's K prime. K prime is right there. And then it says it wants to reflect over the y-axis. Well, point L, I'm starting at point L. 1, 2, 3, 4, 5 to the y-axis. Then 1, 2, 3, 4, 5 on the other side would be right there. That'd be L double prime. K is all the way on the edge. I can see that it's at 10. So if I go all the way across, K double prime would be there. And J is at 6, so it should be at 6 on the other side as long as I stay on the right line. -6, that would be J, double prime. Drawing out my triangle here. Boom, done. That's all it wanted. All right, let's do these now. Are figures A and B congruent? Would you say that those are congruent? To be congruent, everything has to be the same, and it looks like they're the same even though they're flipped, so I would say yes. Which transformation will map figure A onto figure B exactly? I know it's got to be a reflection, and it looks like this is our line of reflection, which is the y-axis, so I'm going to click that one for my final answer. Next one. Are these two figures congruent? It looks like they are. Again, it looks like one shape. If it was a puzzle piece, it would fit right into the other shape. So I'll say yes. Which transformation will map figure C onto D exactly? Looks like I'm going to have to do some type of rotation. How many degrees would it be? Because again, if we're going clockwise or counterclockwise, it's different things. If I'm going all the way over here, that would be counterclockwise. That'd be 180 degrees. Because I'm going from this quadrant to this one, to this one, to this one. So this would be our 90 degree, 180, 270. So if it has 270 as an answer, we could circle that, but I don't see it. So that means we got to go this way, which is the way the clock goes. And that looks like it's only a 90 degree rotation. So it's got to be that one. Are figure in C and D congruent? Again, I would say yes. What are they doing? That looks like a translation. It looks like it's going... Oh yeah, figure C is the starting one, I think it says. So translate figure C to the right. No. Translate it up. Yes. That looks good. Is it 7 units? 1, 2, 3, 4, 5, 6. That looks good to me. Couple more here. Do these look the same? No. This one is only like got a bottom of 1. Looks like this one has a bottom of 2. So I would say no. Next one. This looks like a rotation. Again, I would say this is going clockwise because we can't go counterclockwise on this one, because if it was counterclockwise, again, it'd be 90 degrees, 180, 270, and I don't see a 270 down here anywhere. So I'm going to go clockwise, 90 degrees, and that's my final answer. Last one. Are they congruent? Looks to me like they are congruent. Now we got to figure out how we would do this. It looks like I would have to rotate it at some point. If I rotated it clockwise, 90 degrees, I'm just going to try my best to draw it here. It would be, your rule would be the same as counterclockwise 270, which would be, it's on my other video with rotations. I can actually just find that for you here real quick. Where's my rotations video? Right here. So a 270 degree counterclockwise rotation. This was our chart for this. I kind of drew all over it. See if I can get rid of some of those. I don't know if I can. But if you need to write that down, I would just go to that video and find them. Hopefully I pushed the back arrow. Okay, no, we're good. So if I'm rotating it counterclockwise, I would do the 270 degree rotation and end it up right here, because I can just kind of tell that it's going to be an easy reflection after we rotate it. So if I rotate it, I believe it would look, well, you could rotate it a couple different ways, I think. I might change my mind here. I might just rotate it clockwise 90. That might be better even. So if I rotate it clockwise 90, it should look like that shape right there. I'm going to see if I can draw better. Okay, it would look like that. I'm going to let you figure that out. That would just be a 90-degree counterclockwise rotation. And if you're confused on those, you got to go watch that video again. And then this is just a reflection down. Do we have that as one of the answers, though? So we know that it's going to have to be a rotation and a reflection. So the translate can leave. Translates out. This one has a reflection. Does it have a rotation? It's got to translate. It's got to be not right. Rotate is good. And then reflect. It's got to be that one.